showing you how to set up a water wheel case to try out a new exciting feature in Doriflow version 1.2.1, where you can fix a center of mass so that it can rotate on itself and not floating in any directions. I will also be including the file in the description box below, so feel free to download it and use it in your own time. So first we add our domain, and I recommend you to set this to 111 first. So the lowest point of the domain starts from origin. In that way we can get rid of a lot of unnecessary fluid divergence error. Then we can use the 3D cursor to scale it up to around 10 meters, maybe a bit in the X direction, and assign it to be domain. Then we can add a water wheel models that I prepare beforehand, and we can also add a fluid by just copy a domain and then scale it back in X direction, assign it to be fluid. We can then go to the wheel, Doriflow solid, choose a fixed center of mass, and also click on no rotation around X and Z axis, so that in this case it will only rotate clockwise or counterclockwise. Do it the same for other wheels. Next we can go back to a domain and try out a resolution of 100 this time, and because the physics is less complicated now, we can actually ramp up the time step to 2, viscosity to 0.08 for example, and then we can compute fluid solid motions. And also we need to keep this window open because this is where the solver runs. During the simulation you can actually pause and resume the simulation without any issues, like so. Okay, so now it has finished. We can then import the solid motion. You notice every wheels will now be keyframe. Scroll through the frame to see how the wheels rotate. Then we can go back to domain, mesh, import fluid particles, particle to mesh. Scroll through the frames to check out the fluid dynamic. If you notice a droplet of water is a bit too unrealistic, you can click on the DF mesh geometry node and try to reduce the radius. And you can also increase the threshold to actually delete all the water particles that is too far from the bulk, like so. Then we can close the tab, go to the white water and compute. You can also pause and resume the simulation without any issues. And because we use the GPU to compute the white water particles, so we need to pre-allocate the memory with 600k of particles, and sometimes you will find yourself exceed that number, so you can just simply reduce the generation intensity to 1.02 for example, or increase the maximum number of particles and compute again. And as you can see, we still passed the limit in this case, so now I will need to reduce this number to around 0.35 to significantly reduce the generation intensity for the particles. Hopefully it will work this time. Okay, so now we successfully computed the white water particles with around 196k particles. We can then import the foam and the bubble particles as well. Scroll through the frames. We can then turn it into an icosphere. You can hide a fluid particles and also the fluid mesh to visualize how the foaming particles play out in the scene. Then we unhide them. Next we can add a plane, and then we can add a point light. And then you can set all the options to the same as the previous tutorial. Go to the render view, hide a domain, and also hide a fluid cube. You can then hide the particle views. And because the white water particle is too big, so it gives you a sense of unrealism in the scene. So you can click on the foam fluid, go to the geometry node, go to the instant on poise node, and reduce the particle radius to, for example, 0.05, and go to the render view. So now you have a much more realistic whitewater particle scene. And that should be it. Okay, so now I will go ahead and render the animation by going to the main, render Doriflow animation, go to the camera view, and I want it to be 1:1 of the aspect ratio this time. We can start to rotate the scene to view. And you can also use the render image to test out for 1 frame. And sometimes once you set up a scene, you find that you lose the frame handler for DF mesh. So as you scroll through the frames, the DF mesh will now be frozen for 1 scene. In that case, we can go to the mesh and import the fluid particles again, particle to mesh. And also we need to import the whitewater particle again and build geometry node. We can then go back to a render Doriflow animation, choose an output path and click render final animation. Also, during the rendering, you can stop the process by pressing the escape button. However, the memory will be fully loaded, so the Blender might crash. If that happens, just reopen the Blender, re-import the particles, and render from the last frame that it crashed by changing the start frame this time. This is the final result. As I scroll through the frames, you will see a different rotation dynamics from the 4 wheels. Also, if you feel like you don't have enough whitewater particles, feel free to go back to the whitewater tab, change the variables and compute again. You don't need to compute fluid and compute mesh again. That is the advantage of the Doriflow separate module computations. Thank you.